In this problem, we are given four trigonometric products and we need to convert them to a sum or difference of sines and cosines. So let's begin with number 1. So here we have 2 times sine 3 theta times cosine theta. Now if we suppose that 3 theta, if this is a and theta is b, this is going to be the sum of two sine functions. So sine of a plus b plus sine of a minus b. So we get sine of a. So a here is 3 theta plus b, so b is theta, plus sine of 3 theta minus theta. So we get sine 4 theta plus sine 2 theta. So sine 4 theta plus sine 2 theta, that is the product 2 sine 3 theta cos theta expressed in terms of the sum of two sines. Moving on to the second part, here we have 2 times cosine 3 theta times sine 2 theta. For this, we can use the second formula, 2 cosine a times sine b. We're going to get sine of 3 theta plus 2 theta. So here we are assuming 3 theta to be a and 2 theta to be b, minus sine of 3 theta minus 2 theta. So this is going to give us sine of 5 theta minus sine of theta. Now coming to number 3, so we have 2 times sine 4 theta times sine 3 theta. Now clearly we see here that this corresponds to this particular formula. So this will be equals to cosine of, so we will take a to be greater than b. So we'll assume a is 4 theta and b is 3 theta. So 4 theta minus 3 theta, that's going to be simply theta, minus cosine of 4 theta plus 3 theta, so that's going to be 7 theta. And finally we have number 4, 2 times cosine of 7 theta multiplied to cosine of 3 theta. So this will be equals to, so we'll use this formula. So we have cosine of 7 theta plus 3 theta, so that's 10 theta, plus we have cosine of 7 theta minus 3 theta, so that's 4 theta. So this is how we can convert each of the trigonometric products as and express it as a either sum or difference of sines and cosines.